Hey, I'm back. Let's do more questions. All right, so now we're going to work on the problem set about inscribed and central angles and see where we can go from there. So it says use all of the theorems to find the following angles and arcs. Fine. So it says, what do AB, AD, and AC have in common? AB, well, they all start with A, and that's because A is the center, and if they all start with the center, they are all radii. Okay? The plural of radius is radii. What type of triangle is CAD? Okay, well, CAD would be a triangle. It kind of looks obtuse, but I'm probably going for more than that. AC and AD are both radii, which means AC and AD are congruent, which means that triangle CAD is isosceles, because there are two congruent radii. All right, then it says find the measure of x and y and z. All right, so if that's isosceles, if this little angle right here is 40, that means this angle over here is also 40, which would mean that why is it doing that? That y is going to be 180. Hang on, I think I know why it's blinking at me. There we go. Which means that y has to add up to 180 with the two 40s, which means that y is 100. And then it says find angle Z. Well, Z and 100 make a straight line, so they are a linear pair and therefore add up to 180. All right, so there's the measures of X, Y, and Z. I've written them on the diagram. Then it says find the measures of some arcs. So arc CD would be this one right here. It's across from 100. 100 is a central angle, so CD is 100 as well. I don't know why that just dinged, but it did. So that's 100. Arc BC would be this one over here. Well, that's across from an 80-degree angle. So it would be 80 degrees because 80 degrees is a central angle. And then we want arc BD, which is this last one, and that's across from a diameter, which means that thing is half of a circle, so it's 180. All right, number 2, find the measures of all the missing arcs and angles. Well, that's a bunch of central angles in this one again. So if I'm supposed to find all the missing arcs and angles, I know the central angle equals the arc. I know I've got some linear pairs. Maybe I have some vertical angles. I don't know yet. So if this is 82, then the thing across from it is also 82. If this is 63, I've got another 63 right there. And NOR looks like a diameter, so that has to add up to 180. So 82 plus 63 is 145, which means I have, what, 35 degrees left for right here, which means this is also 35. And then it looks like MQ and NR create some vertical angles. So if this is 63, so is that. So then this is going to be 63 again. And this whole thing would need to add to 180, which means I have 117 left over, which makes that 117. Okay. Now down to the bottom, quadrilateral QNOP is cyclic and inscribed in circle M. Find the measures of all the missing angles and arcs. Okay, so those cyclic quadrilaterals were the things we learned about last time, where the four corners touch the edges of the circle. And the rule was the angles across from one another, the angles opposite from one another, have to add to 180. So if I know that this is 120 right here, and I know that M is the center, which makes this a diameter, that left-hand side has to add to 180, making this 60. And I know that this angle right here is an inscribed angle, and it's facing 120, which means that it's half of 120, so this is 60 degrees. And then I know that this angle is another inscribed. It's facing 60 degrees, so it has to be half of 60, which makes it 30. I'm shaking my head at my son who wants another granola bar. I don't know about you guys. I know many of you are teenage boys. I am petrified for when my boys are teenagers because they are eating everything in my house. And since they're in my house 24 hours a day, my food supply is decreasing at much more than a linear rate. Yes, you can have a mint. Okay. Not to be sexist about that, boys, girls, I know you guys all eat, but there's something about boys, especially when they're young. Max moves constantly. Can you stop crinkling that? You're like a person in a movie theater.
I'm trying to push it out.
Okay. Back to the math. So that's 30, that's 60. This makes a triangle, so this has to be 90. Hey, now's a good time for a new theorem that I didn't list, but it's important. There is another theorem that we haven't talked about called Thales Theorem, or Thales Theorem. I don't know. I'm pretty sure he was Greek, so I'm not exactly sure how he would have pronounced it, but it's either Thales Theorem or Thales Theorem. And it says this: when you have an angle that's inscribed in a semicircle, in other words, the end points of the angle are end points of the diameter, you will always get a right angle, and that comes up a lot. Now, Thales theorem is really just a specific form of the inscribed angle theorem. It's 90 degrees here for two reasons. Reason number one, I had a 30 and a 60 already, so I needed the 90 to add up to 180. Reason number two, that 90-degree angle is eating half of a circle. And that half of a circle would be 180, so the 90 is half of the 180. So Thales theorem says an angle inscribed in a semicircle is a right angle. Yep, that's a cat. That's Pete the cat. All right, well, I'm going to keep going because the question said, find the measures of all the angles in arcs. So let me erase some of the nonsense I had here. So this was 60, this was 30, that was 90. So if I use Thales theorem again, Thales theorem over here would say that O is also inscribed in a semicircle. So that's another 90. But this time I have a 70 right here, which makes the inscribed angle N35. I shouldn't say N, I should say PNO. And if this is 70, that has to be 110, so the whole thing adds up to 180, and half of 110 is 55. All right. Okay. And then it says, what did you notice about Q and O? Q and O are both right angles. So in this box, I want you to write Thales theorem again. And I want you to draw a simpler picture that if you have a semicircle and you inscribe any angle in that semicircle, like this one, that would be 90. If I did it with a different color in a different spot, still 90. If I did it on the other side of the circle, you guessed it, still 90. Even if I make it an itty bitty line first, still 90 degrees. So angle inscribed in a semicircle is a 90-degree angle. Okay, last but not least, you have a problem set here with this, okay? This is just a problem set for you to work through. You're going to have another problem set in Delta Math. So this is good practice. You should do this as well as the other stuff. I am going to make a very fast video going through this problem set. So I would like you guys to try this on your own and then see what you can do with it. Just scroll through it and, you know, practice it without the answer key in front of you and see how you do. And then you can work on Delta Math. Still need to find a better stop. Haven't found the better stops area yet. Come on. I can't find it. There it is. Bye.